Thanks for tuning into our panel, How to Run Epic DJ Livestream Events. Today, we're joined by 4 distinguished guests. From Pon de Beats, we've got Shiz. From AniParty, Sean. From AnimeltUP, Marcan. From AniCLover, myself, James. We're going to talk about how we operate our livestream events and put on DJ festivals over the last couple of months. I'm going to start off with a number of different ways that you could do it, and also the way that we chose to do things. And then we'll go through one by one, and each of us is going to describe some of the unique aspects of our setups, and then go into Q&A. There are lots of ways to run a DJ livestream festival, so don't just go by what we chose to do. There are also a number of other ways that other DJs and other groups have done their events that I'll review briefly. First, and probably the simplest, is just have a schedule. Hige Driver's Hitoriani event was done this way. This is better for organizers who already have a lot of clout. What he did was put up a web page and organize a schedule. Each DJ would stream to the service of their own choice at their own channels, and people would just pull up this web page with the schedule and follow along by following the links. This minimizes the overhead on the organizer, and individual DJs get traffic, and they can also use whatever service they typically use. It doesn't have to be the same service. Twitch, YouTube, even smaller places like Tweetcasting, doesn't really matter. Another way of doing things, a raid host relay. This is more specific to Twitch, where a current DJ, when they're done performing, will raid the next DJ. That means that the organizer doesn't need to coordinate these transitions, and the audience will be kind of swept along by the series of raids and follow along across the different performers. DJ Evangelion's worldwide Toho events were run this way. If you want to stream to a single channel, you could share your stream key. Each DJ is given the stream key to the channel, and they take turns streaming to the channel. Now, a DJ cannot begin streaming to the channel until the previous DJ has stopped streaming. So during the transitions between DJs, the channel will go offline momentarily, but the audience gets to stay on the same channel the whole time, and the channel retains all of the VODs and the followers. An example is Anisong Hijack is done this way. You could also pre-record the whole thing. DJ performances could be recorded well in advance. Advanced video tools could be used to produce a really high-quality video. All of these videos can then be strung together, and then they'll be sent to the streaming service at the appointed time. There isn't as much opportunity for live interaction from the DJs with the audience this way, but that isn't always necessary. Tsunemiku Digital Stars 2020 Online was done this way. Finally, the way that the 4 panelists here do our streams is via an RTMP server. Here, individual DJs stream to a custom server, and then an operator will pull streams from those custom servers, do compositing overlays, coordinate transitions, and generate the final stream, which is then sent over to the streaming service. This enables the panelist setup to be easier because they don't have to worry about all the setup that they would need as an independent streamer, overlays, other things. They just need to make sure that they're getting audio and some kind of video feed. And then all of the other interactive elements, chat boxes, notifications, standard things that we often expect from streams, as well as more complex things like coordinating views with multiple performers on stream at the same time, or transitioning one playing performer into another with a crossfade. These are all possible and done centrally by the operator. Now, let's get into our setups. First up, Shiz.
Good afternoon, everyone. My name is Shiz, and I'm a stream operator and general tech guy for Pon de Beats, which is a in fact, Netherlands-based anime and anime culture streaming party. So today I'll be talking a little bit about setting up a stream server and all the kinds of things involved in that, just to get you running very quickly. All right, let's get started. So, as just said, the basic setup is that your DJs, all of them, will connect to a streaming server, and then you connect to that streaming server as well, receive the broadcast that the DJs are sending to you, maybe add your own overlay, your own chat, etc., and then send it out to Twitch. So let's take a look how that works, right? Basically what it comes down to is streaming protocols. So what is a streaming protocol? It is a way to get media from point A to point B. Video, music, sometimes subtitles, but let's leave that out of scope for now. There are two major protocols in active use right now, RTMP and SRT. RTMP stands for Real-Time Message Protocol, and it was invented by Macromedia, now Adobe, back in the early 2000s. Initially used for Flash, it is very well supported. It is technically proprietary, but there's a bunch of implementations so that you can basically find it pretty much everywhere. On the other side, there's SRT, Secure Reliable Transport. You'll notice how none of the streaming protocols have actually names related to multimedia. It is fairly new, it's under active development, it's open so you can participate in development and propose changes. And it has some fancier features like rate control, encryption, authentication, and fine-grained buffer management. It is, however, also less supported in general, but OBS does support it. So let's take a look at what we can do to set up a server. There are also two often used server packages. One of them is Nginx RTMP, and the other one is SRS, or also called OS SRS. Nginx RTMP, as the name suggests, is built off the popular Nginx HTTP server and only supports RTMP. It is fairly easy to set up, only requiring minimal changes from a default Nginx configuration, and it builds off the venerable request core of the Nginx server. On the other hand is OS SRS. It supports both RTMP and SRT. It is very easy to set up through Docker, and it has a built-in nice web interface with statistics, connected clients, etc. It does need a little bit of more configuration for advanced use cases, since its buffer settings by default are kind of weird. So, to get you quickly up and running, and also what we did in production, was set up SRS. So, presuming you have a server set up with any of the major cloud providers or elsewhere running Linux, all you need to do to start an SRS instance is the following command shown. That is all. It will set up an SRS server, it will start listening for RTMP on port 1935, the standard port, and it will expose a web interface as well on port 1985, which looks a little bit like this. You can see the connected streams, you can see who is listening in, which should usually only be your DJs and you can even have a little stream preview of the incoming stream from the DJ. It is all rather handy and all nicely built in. So let's take a look at RTMP URL. Right, so when you start OS SRS, it might tell you that this is your full RTMP URL. It starts, of course, with the protocol, and then the host, which is the domain or IP of your server, followed by a path. So the path is divided into components. The first component up until the before last is the path, and the path identifies the stream, so you can have multiple streams running through the same stream server. This is pretty common. You could even host multiple parties on the same server at the same time if you wanted to. After that, the very last part of the path component is the app in RTMP terminology and the stream key in normal OBS or Twitch terminology. This identifies the client. So basically, in your case, that's the DJ who is streaming to your server. And Twitch uses it also as a way of authentication, so that only the person who sends the correct app, or the correct stream key in this case, can stream to your channel. So when you're talking about with your DJs about setting up RTMP in OBS, what you do not want to do is give them the full URL. With SRS, this will not work, and it will actually fail. What you want to do is chop the stream key off at the end and tell them to put it in the stream key field. This will work just fine. As a random side note, what you can also do is put a space before the URL. This will work, but it's only because of a technicality, and I would never ever recommend it, but it is a fun curiosity. Oh well. So let's take a look about preparing your DJs. So you want to go through your setup with your DJ way beforehand at the setup session. Say, for safety, let's say have it be a week beforehand, so you have time to tweak your setup if something is going on your end. During this session, you generally just kind of want to walk them through configuring their OBS. You want to do a bandwidth test and a rate test. Not only peak, but also maybe sustained. Like have them play a mix for, I don't know, an hour and a half. Could just be a sound file on their computer, just to make sure that there are no weird dips in their network. Once you have done that, you can establish what rate you would like them to be streaming at to your server. Once you set all that up, it's usually handy just say a day beforehand to do a rehearsal, see if nothing has changed in the meantime, if everything still works, maybe do the bandwidth test again to make sure the internet is still as stable as you expected it to be. And hopefully, then just before they're going to get live, you have a check session. Usually we coordinate these sessions on Discord. So let's say 15-ish minutes before they go live, you talk to them, connect to them, have them connect to the server, and they can generally just stay connected until it is their turn to go live. What we at Pon de Beats do is just give them a heads up whenever we're about to switch over to them, and then they will start playing. Right. So, there are connectivity issues sometimes. As if this is all going through your home connection, you might not have the best internet, so the bottleneck may not end up being not the DJ, but you. So we thought about this, and why run OBS locally? This is more so just a thought experiment. At this point, you should be all set up and ready to run your server. This is some fun side project we've been working on. So what if you could do this? Set the DJ to the RTMP server, have it set to OBS on the server, and then send that to Twitch directly. There's no thing from your involved at all. And you can just lay back. Well, of course, there's a couple of problems with this, such as not really having control over scenes, but it's a fun experiment, so we started playing with it. So we had some initial experiments of actually running OBS itself on a server, but it turns out that OBS is pretty GPU required. It mostly ended up in the server being incredibly overloaded and taking around 70% of an 8-core Xeon to render a single video. Not very successful. So we went back to the drawing board. Do you actually need OBS itself? What if you could run your OBS with something else, your scenes? So, well, in Linux multimedia land, you have two main offerings, FFmpeg, or libav if you will, and GStream. So we decided to take a look and see what we could do using FFmpeg. So the plan of action was to parse OBS profiles and scenes, generate FFmpeg mappings, and then a complex FFmpeg filter chain that would basically allow you to represent your OBS scene as a very long FFmpeg command. Being able to make use of FFmpegs relatively being made for being ran on high-powered CPUs and not requiring on GPU acceleration. Right. So we had some iterations of that. This was a first success. And then we ended up adding chat, first through a simple Twitch REC relay, later by embedding the browser. And at some point we had a fairly workable proof of concept. So we didn't end up pursuing this, but we do think it's an interesting experiment for those with unstable connections and where you don't need to have control too much over your scenes and scene transitions. It's mostly just a fun experiment, but if you would like to play around with it, it's at my Git at weaboot.software/shiz/hemisphere. In conclusion, be safe, have fun, mess around with things a little bit. It's not the worst thing in the world if things go wrong. And also, no matter how good your setup or your internet are, if your computer drops out during a stream, as may have happened at Pon de Beats, it's still not very useful. So, arrange for working power cables. Thank you very much for listening, and next up will be AniCLover to talk about better ways about setting this up in the cloud by using GPU VMs.
Hey folks, I'm Sean and I'm the stream operator for AniParty. We are an Anisong DJ collective that does events along the US Northeast, predominantly in New York City and Washington, D.C., as well as at major conventions all over North America. I'll be covering how to set up a stream operator virtual machine, or VM, using Google Cloud Platform, enabling anyone, regardless of resources, to start running a geographically distributed streaming event. Obviously, this presentation is tailored towards DJ events, but it could really apply to any event of this nature. So why have your streaming operations center located in the cloud? Well, for starters, it evens the playing field for people who don't own dedicated beefy personal rigs that have tons of graphics processing capacity. While you're better off investing in such a rig for regular daily streaming, running streams for a few hours once a week or once a month on a cloud server is only going to run you on the order of about $10 to $20 per pay cycle, generally on a monthly basis. That's on the higher end of the estimate. So speaking of cost, the other reason why Google Cloud is ideal for beginners is because they throw $300 worth of free credit at you right out of the gate for a new account holder. This will last you quite a few pay cycles, potentially stretching out that free credit across the entire year, depending on how infrequently you run your events. Another reason to run your stream operations from the cloud is because your residential internet service provider is the flimsiest, most unreliable, most brittle link in the operations chain. And the beefiest rig doesn't mean anything if it can't reach out to Twitch or YouTube, or your DJ's streams can't inbound on it successfully. Now, with it in the cloud, the operations server is well guarded by the most reliable networking infrastructure. And if something goes haywire in the network somewhere, well, at least you know the problem isn't on your end. And of course, you also get the fringe benefits of being able to run a stream pretty much from wherever, as long as you have a machine with a browser and a reliable enough local connection to connect to it over a remote desktop. So some prerequisites: a Google account. You need a credit card to sign up, but of course, because of the $300 worth of free credit, it won't run you anything for at least the first couple of months. Some basic IT know-how. So for Linux, it's really not much more than being able to navigate directories and follow straightforward instructions to run some commands, download, install, and run software via online tutorials. And you'll need some fundamental knowledge of OBS and how to add external feeds, specifically RTMP or SRS to OBS. Some of this will be covered via the rest of the panel, and there are also plenty of pointers on Google on how to handle this. So as far as architectural options, there are really two here. You can split the two functions, the RTMP/SRS and OBS, into two separate VMs or have them reside on the same VM. So this point may be a bit contentious, but I feel for a beginner, personally, configuring them as two separate boxes is more sensible and more straightforward. So that's what I've chosen to go with. Basically, your RTMP SRS machine running Linux is the initial ingest point where all the performers stream to, and it simply aggregates all those performer feeds and forwards them to your OBS machine running Windows, which is where you'll be spending most of your time as an operator, controlling graphically over a remote desktop. So the next slides will cover actually provisioning and deploying these two VMs. The initial steps are pretty straightforward. Just log into your Google account, go to cloud.google.com, navigate to Compute Engine and VM instances to begin setting up your VMs. So you'll be presented with this menu, and we'll start by configuring the Linux RTMP/SRS ingest VM. Ideally, you'll want to go with a region that is relatively central to all your performers. For example, we at AniParty, we're located principally along the US Northeast, so we have performers in the DC area as well as further north in the New York area and in Boston. So the top major data center metropolis in our region is in Northern Virginia, so it serves as an ideal central aggregation point. If your performers are more geographically diverse, this doesn't matter quite as much. Just try to be as central as possible. For instance, if you're pulling in feeds from Europe, Southeast Asia, Tokyo, the difference between having your VM in Iowa versus Northern Virginia isn't really going to make much of a difference, so don't sweat it too much. For the operating system, Ubuntu is the most newbie-friendly Linux distribution, so that's highly recommended if you're not as familiar with Linux. And for all these other options you see on the screen, you can really just leave them as default, because as an ingest VM, it's not really too heavy on the processing resources. Next is the Windows OBS machine, and this is, again, where you'll be spending most of your time as the operator. Similar to the Linux VM, select the region that is most central to your performers. So one caveat to point out here is that some hardware configurations may not apply to certain regions. So you have to play around a bit with the options to see what hardware is offered for you for your particular region. And as I pointed out, it isn't critical that you nail this, that you get the centrality perfectly optimal. Just try to get it as close as you can. For processing resources, this is where you'll be spending most of your processing budget. You'll want to lean towards a heftier configuration. Here I'm showing 4 vCPUs and 16 gigs of RAM. That's really on the lower end of the minimum requirements. Video processing is incredibly resource intensive, so if you're in doubt, go with more resources. You'll definitely want a dedicated hardware GPU because it allows you to offload some of the video processing from the CPU. Another caveat here is that not all GPUs are supported by OBS, and you may find that when you boot up the program and try to assign the GPU that you configured here, it won't appear. And it's not always consistent with the official documentation on what GPUs are supported and what aren't. So be prepared to mess around a bit here. I'm showing the NVIDIA Tesla T4, and that's what I roll with for our operating server. And as far as the OS is concerned, most Windows OSs work fine. I personally roll with the Windows Data Center offering. Finally, configuring networking. So you'll navigate to your VM Instances tab, and you'll see your 2 VMs, which you've provisioned listed here. The external IP of your Linux VM is what all streamers will send their data towards. So in other words, this is the IP you send out to your DJs, your performers, and instruct them to set their streaming destination to. So your Linux VM will communicate to your Windows VM based on either the Linux VM's internal or external IP, with internal being highly preferred for obvious reasons. This is the IP that you'll enter into your Windows VM's OBS setup. So for example, if you're adding an external stream feed to OBS via a VLC source, when you configure that source, this IP is what you'll specify as the source of the feed. And that's pretty much it to get started with the streaming operations server on Google Cloud Platform. As I note here, there are plenty of options that can be used to enhance and optimize the resiliency and the performance of your setup, such as by statically assigning an IP address, or by leveraging Google's TCP endpoint proxies. And there are obviously a lot of options to more intelligently craft your workflow, some of which will be covered later in this presentation. But for a no-frills, zero-to-start streaming setup, this is what I feel to be the simplest, most straightforward, and effective method to get your feet wet. So that's it for me. Feel free to reach out with any questions, requests for clarifications, or if you just want more detail on anything I covered. Again, I'm Sean, and I'm the stream operator for AniParty.
Hey folks, I'm Marcan, and I'm the stream operator for AnimeltUP, an Anisong DJ event based in Tokyo. So you've figured out how to use OBS to run events with multiple remote DJs, but how do you scale that up and polish it into a 6 to 8 hour event? I'm going to talk about how I do things for AnimeltUP and a few tips and tricks you can use to spice up your own event. You've already seen how in order to receive feeds from your DJs, you'll need some kind of RTMP server to act as a middleman. The simplest solution for doing this is called Nginx RTMP. Nginx is one of the most popular web servers in the world, and Nginx RTMP is a plugin that allows it to work as an RTMP server too. Installing it and setting it up is super simple, and you will find many tutorials for doing so. Here's a quick overview of the most important bits. First, I'm going to assume you already have a server or VM set up, probably in the cloud, though you can certainly do this using a local machine too if you want, if you're running a large-scale local event or something like that. I recommend using Debian Linux 10 Buster, which comes with all the required packages. Once you have a fresh VM or server up and running, install Nginx and the RTMP plugin with this command. Once that's done, you have to edit the Nginx configuration file, which is at etc/nginx.com, and add a section at the end that looks like what you see on the screen. This tells Nginx to set up an RTMP server on port 1935, which is the default RTMP port. The wait key and wait video options are important to make sure that when you connect to the server, the audio and video come in at the same time. This avoids problems with getting stuck playing only audio. Then, this sets up an RTMP application called MyStream. You can ask your DJs to stream to this application using a URL like this, where 1234 is your server's public IP address. You can use whatever stream key you want, such as DJ1, and then the stream will be available for streaming at a URL with the stream key appended, like this. You can use the OBS media source type, and just type in this URL, and you're all set. After editing the configuration file, save and restart Nginx with systemctl restart Nginx. And that's all it takes to receive an RTMP feed from one OBS to another. Now let's talk about audio quality. Since you're running a DJ event, the focus should be on the music, so you'll want to have the highest quality audio possible for the benefit of your listeners. I'm going to give you a little tip that will greatly improve your overall audio quality. This is useful for anyone streaming with OBS, not just DJ events, but it's especially important when a chain of OBS instances is involved, such as DJs streaming to you, or even DJs streaming to VJs who then stream to you, which is something that we've also done for AnimeltUP. When using OBS, you will typically use the AAC audio codec, and in fact this is basically hard-coded for normal streams and cannot be changed. The issue is that OBS by default does not use a high-quality AAC encoder. Even at high-quality settings, there is a subtle but noticeable loss of quality, and this gets worse the more instances of OBS are involved along the chain. The end result ends up sounding muddy, like a low-quality MP3. It's somewhat subtle, but it's a real shame for a music event, and it's really obvious with some genres like chiptunes. Unfortunately, this is a pervasive problem in the streaming community, and many streamers are affected. Thankfully, there is a fix. First of all, avoid Streamlabs OBS. Streamlabs OBS is broken in this regard and has been for years, with no ability to use the higher quality codecs and no interest from the developers in fixing it. You should make sure that you use the original OBS Studio, and make sure all your DJs do so too. Once you're on OBS Studio, what you need to do depends on your OS. If you're on a Mac, congratulations, you're all set. OBS on macOS will use Apple's high-quality AAC encoder by default. If you're on Windows, then the solution is to, as funny as it sounds, install Apple's codec. OBS on Windows can use Apple's AAC encoder if it is installed, and it used to come with older versions of iTunes. Unfortunately, the current version no longer includes it, so getting it is a bit awkward. First, make sure you have 7-zip installed. Then, visit the link on the screen, which will take you directly to the right version of iTunes from Apple's download server. We have to do it this way because they no longer have a link to this anywhere on their site, even though the file is available. Once you have downloaded the iTunes installer from the link, right-click on it and open it in 7-zip. Inside, you will find two files called Apple Application Support, a 64-bit version and a 32-bit version. Choose the file that matches your OBS version, which is probably 64 bits these days, and install this file only, or both if in doubt. Make sure to keep the installation path at the default. This file installs just the codec and a few other support files, not the rest of iTunes. You can send these files directly to your DJs for their convenience. If you're on Linux, there is a different AAC encoder that OBS can use called libftk AAC. The instructions for different Linux distributions are on the screen. If you're a Linux user, you'll already know what this means, so I'll skip the explanation. Finally, make sure you restart OBS after taking these steps. To double-check that the encoder is the proper one, open up OBS, start a stream, and go to Help Log Files View Current Log. Near the end, you should see a section that mentions either Core Audio AAC on Windows or macOS, or FTK AAC on Linux. If you see this, then you know you're using high-quality audio. Make sure anyone using OBS follows these steps, both you and your DJs. For your DJs, I highly recommend setting the audio bitrate to 320 kilobits per second for the streams they send to you. This ensures the lowest possible audio quality loss until the final stream, where you will encode at the correct bitrate for your streaming service, usually 160 kilobits per second. Alright, let's look at how our AnimeltUP setup works. I'm going to cover our general OBS setup, as well as some tips and tricks for running OBS productions on Linux, which is the OS that I use on my desktop computer. In order to run a multi-hour stream smoothly, you'll want to make sure that you have a clear set list of what DJs come in what order. What I do is set up scenes and OBS in the same order as the set list, and then all I have to do during the event is continue advancing to the next scene. In order to have smooth transitions, it's important that the streams for both the current DJ as well as the next one be active simultaneously. Normally, OBS will only activate sources when they are part of a currently active scene, and this does not include the upcoming scene selected in studio mode. If you were to just switch scenes containing a single RTMP source, you would end up with a choppy production, as the new scene would take a few seconds to connect to its source. You also won't be able to test the upcoming DJ while the previous set is running. To fix this, what I do is always have all sources duplicated into the previous scene. The current DJ actually has the next DJ under them, invisible but active. Then I can actually fade in the audio of the next DJ and fade out the current one before triggering the scene switch. The way my transitions go is usually like this. First, during the previous DJ's set, I contact the new DJ and make sure they're all ready. We coordinate over a Discord call. Once their stream is up, I verify that it shows up in my preview of the next scene. You may have to toggle visibility of the media source to reset the stream, in case it didn't connect properly. At this point, the stream audio will be set to monitor only in the advanced audio properties, so any audio coming in from this DJ will not be audible over the stream, but only to me. I can confirm the audio levels and make any adjustments necessary. As the transition time approaches, I tell the DJ to stand by and not send any audio. I then patch in the stream audio, current DJ plus my announcing voice, into the Discord call so the next DJ can monitor the stream in near real time. They are queued to start their set when I am about halfway through introducing them on the stream. Since there's usually about a 2-second lag in the RTMP feed from the DJ to me, this means that they will come in pretty much as their introduction is finishing. At this point, I will switch the upcoming DJ to monitor plus stream so they are on air and make sure their fader is up. As the current set ends, I will fade out the previous DJ, unless they end on a fade out themselves, as I start speaking on air. If all goes according to plan, the next DJ will start playing music right on cue as their introduction ends. Then, once the music is running, I trigger the OBS scene switch, which transitions the video. At this point, the old DJ is no longer active, and they can end their stream. I then stopped feeding program audio to Discord so as to not loop back their own audio to the current DJ and confuse them. You'll have noticed that I have this little frame set up in OBS with the DJ name and whatnot. I like using this style of frame as the inner space is also an exact 16:9 aspect ratio, which means I can just shrink DJ's feeds into it and they don't have to worry about graphic elements overlapping their feed, except for this little detail on the right side. The frames are just PNG images with a transparent inner area overlaid on the overall frame. But how does this cool transition work? Actually, it's just a stinger transition done with a video file that looks like this. It's carefully designed to seamlessly overlap the per DJ frames, and the underlying scene is switched halfway through the transition video. This is all configurable in OBS. There is some subtle engineering to make sure it doesn't cause any artifacts with alpha blending and is completely seamless. I can't fit that into this short presentation, but give me a shout if you're interested in the details. Finally, let's look at how the OBS setup works on Linux. First, I do my final stream audio mixing inside OBS. This is because OBS ensures that audio and video are synced properly from sources to destination, and there's no reliable way of pulling audio from sources into external audio processing and back into OBS under Linux. So the mic ducking effect, which is a sidechain compressor, is done using OBS's built-in effect, copied and pasted into every source, and I use the OBS mixer to monitor and mix my RTMP sources. OBS takes in mic input from an external jack source, and this is where things get interesting. Linux audio is actually somewhat complicated, with different audio systems serving different purposes. The two that matter here are Pulse Audio and Jack. Pulse Audio is used for general desktop stuff, and Jack is used for low-latency audio production tasks. I actually use both for AnimeltUP. This is just a brief overview of what's involved, which might give you some ideas as to how you can do something similar yourself. My main audio setup uses Jack and an app called Carla, which lets me connect together audio sources, destinations, and plugins. This is where I do the microphone filtering, a noise gate, add a bit of reverb, and control when my mic is on and off air. Since OBS has a Jack audio source, it can pull directly from Jack into the stream. But OBS does not send monitoring audio out to Jack, but rather to Pulse Audio. Pulse Audio instead can itself talk to Jack, so I loop back the OBS monitoring outputs into Jack in order to feed them into the system. Discord is also looped into Jack via Pulse Audio, and this is how I do things like feed program audio into Discord or just my mic when off air. We also tend to have a Discord call at the end of events with all the DJs saying a few words, and that is how this is patched into OBS. Controlling the Carla knobs and the OBS mixer manually with the mouse would be very awkward, so instead I have a physical controller that I map to the various features. It's a MIDI controller, and I have a little Python script that maps some faders to OBS sources dynamically. I can toggle monitoring and stream output using buttons, which changes the audio modes and mute in OBS, as well as trim the volume with this knob at the top and fade the overall source in and out. Other faders and buttons are mapped to things like mic on and off in Carla, monitoring level, and switching scenes in OBS. The Python script takes in MIDI from the controller and uses the OBS WebSocket plugin to control it, as well as Carla's OSC support. And that's it. It was a lot of information to cram into 10 minutes, but I hope this gave you a bunch of ideas as to how to put together your own polished online DJ event. Stay safe, everyone.
For AniCLover, I think of things like a marathon. Since this t-shirt became obsolete, we've streamed nearly 80 hours of weekly content, plus festivals, AniCura Unison, AniCLover Series on top of that. These have been long events, right? 10, 15 hours at a time. And so I really want to focus on three key things today. First, network resilience, how to prevent the internet from disrupting the show. Second, fatigue, how to use control surfaces and tools to prevent me from disrupting the show, especially since in scheduling there's a tendency for headliners, like a big head, to show up 10, 12 hours into the show when I might be at peak tiredness. Third, audio consistency, how to make sure that the audio is consistently good week after week and from beginning to end of a long show. First, network resilience. With up to 23 different DJs coming in from 7 different countries over 3 continents, we need to minimize the vagaries of the public internet and maximize stable bandwidth. For the majority of the distance, we handled this by using Google's Cloud TCP load balancer. Google has edge points of presence all over the world, a few milliseconds ping from anybody. By using this service, packets from a DJ will go over the public internet only a short distance, and the whole rest of the distance to our RTMP server will be done over Google's private network, which was quite stable for us and allowed us to have a single server address for all the DJs with all the routing handled magically. That leaves the DJ's local ISP connection as the weakest link. Since we're all sheltering in place, a roommate or a family member might suddenly fire up a big download and choke the local upstream bandwidth. To compensate for this, we asked all of the DJs using OBS Studio to select this dynamically change bitrate to manage congestion option. This will cause the video stream to quickly drop bandwidth usage in case of congestion, but maximally preserves audio to keep the party going. This has worked well in a number of past emergencies, but only for OBS Studio. The similarly named option in XSplit and Streamlabs don't work that well. Next, fatigue. Right. Fatigue is mainly concerned during transitions, where I might mess something up when I'm transitioning from one performer to another. And that mainly means mechanizing some of these manual actions, right? Like normally if I was going to do everything with the mouse, I might flip to another performer, and I might have to fiddle this in order to reload their scene. And then when I'm ready, click the transition button. And I might mess something up. And if that happens, then the transition doesn't go smoothly. Plus, I can't easily control the faders with the mouse at the same time I'm clicking on all this other stuff. And that's where having these control services really helps. These control services then let me control scenes here. So I've got scenes here, and you'll see that I switch between scenes here. And you'll see there's a colored light here. This does my RTMP media source loading. So this will reload a source 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And that's the numbering convention that I have, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And that lets me control the loading without having to double click on stuff. And I can make sure that I've targeted the right thing. Then I've got faders here. And that helps me control the volume transitions between performers. So let's imagine I'm doing this now for a show. What do these controls allow me to do? Well, first of all, the yellow means this is where I've been so far. The white is the last thing that I clicked on. So I know my next performer is going to be here. Same thing for the media sources. So I'm going to bring up the scene for the next performer, performer 10. And then I can see here that performer 10 in my stream stats is streaming to me right now. And so I can load up 10 and they appear on screen. I can look at the screen, make sure that everything's good. I can see here that their audio is live. And then I can unmute that audio. All right. So here I've got Mikan Maru. And then when I'm ready to go, I can hit the load button here and then execute the crossfade in a way that I really couldn't do with the arrow button. And then the lights have updated, so on my next move, I know exactly where I need to be, moving all the way up. Last thing on fatigue is I don't want to have to ever alter any sources during the show. So I've got all of the performers and their source customizations all set up in advance. So you'll see here some performers had a left sidebar, right sidebar in order to match up their screen layouts. These are all done in advance. Final topic, audio consistency. This is pretty important because we are an audio event, right? The DJ music events are very audio heavy. And I have a particular tool chain here that I use for two reasons. So what I have is, of course, all the RTMP streams coming in traditional way, like everyone's talked about before. But I'm not actually mixing inside of OBS. All of these audio sources are set to monitor only. They're not actually getting output to the stream. And this monitor only output is being redirected over to Voicemeeter VAIO 3. And this virtual audio device in Voicemeeter then goes over into FL Studio and lets me use more advanced audio tools to control the sound. And then this gets piped back out over another virtual mic device, which then shows up here in this VB master. So I've got sound here, this is an input, and this is the master output. Now, OBS doesn't normally have a master output. This is actually an input. It's just the only input out of all the inputs that I have that is actually outputting to the stream, right? All these other things, except for these monitor offs, these things don't generate audio. This is the only thing that's outputting audio to the stream. This lets me do two things. One, it allows me to evade a bug. There's a bug where every time you load the stream in the background, there's a chance that it will cause an audio glitch, a progressive audio glitch to occur that'll first cause the stream to pop a little bit and then pop more, crackle, and eventually it'll break up and be inaudible. At that point, you got to quit and restart OBS, and that interrupts the stream. This happened during AniCLover Unison 1, and that's why that stream is chopped up into multiple parts when we ran it. By externalizing all of this out to be mixed externally evades the problem. I can reload as many streams as I want in the background. The problem actually gets exacerbated when you load multiple streams at the same time, which I do. In AniCLover Unison, we'll often load a group of 3 or 4 DJs all at once who need to be on screen at the same time, who are part of a group. And externalizing all of that evades that problem. It also lets me use VSTs for much more advanced audio processing and monitoring than what's possible in OBS filters directly. And so what I have is I've got ozone here for my limiter and additional gain control. When you're below the ceiling, you can get additional gain, and this is good if a performer knocks something, accidentally gets their levels low. I can compensate for that. I have this actually MIDI map to a knob, so I can adjust. I have another place to adjust gain here. In particular, I can boost it by quite a lot. And then I've got a limiter at -4 dB, which seems like a lot, but it really prevents clipping. It gives me a lot of headroom. And more importantly, it means that this headroom is more comparable to the -14 LUFS that we're targeting. LUFS are kind of a loudness standard. YouTube and Spotify try to average or do forcefully average out loudness to -14 LUFS. So that's what we choose to broadcast at. Of course, you got to use your ears, right? So I've always got the IEMs in, but the ears are a bit relative. This gives me a more absolute reference, and also gives me early warning, because if something moves just like 1 or 2 dB, if there's a 1 or 2 dB trend, I might not pick it up by ear, but I can see it here early and make an adjustment before anybody notices. And this is really useful here to make sure that I can see the distribution and make sure everything stays even during the whole show. That's it for my topics. Now, let's move on to Q&A. Okay, Q&A.
Yay.
All right.
Yay.
What IEMs am I using? I guess I'll have to answer that. I'm using the Lear Audio, the Beryllium driver ones. They're really light, so they don't make me tired when I keep them in for a long time. Second question. Oh, this is a good one. How do you monitor the audio input from all the RTMP servers? Anyone? Who wants to take that?
Yeah, like in my case, it's just like OBS has a monitor option, right? So you can just set your sources to monitor only, and you can bring out the fader as long as the source is active. Then it'll go through your local speakers, but it won't actually go out to the stream. And then when you want to go out to the stream, you switch it to monitor and stream, or stream only, depending on what you're doing. And then it's actually going to the stream. So in my case, I map that to the buttons on my control surface, so I can toggle things between just me or the actual stream.
In my case, I do it a little bit simpler and just open a media player on my laptop, which reads from the source, and see if it's all right.
I actually usually do that first, and then once I know that's right, then I put it into OBS just in case.
Yes. I do the same thing, except I have Zala's helping me. So one of the weird things is that if I unmute the source, right, then it goes out onto the stream. So I can see when there's audio because there's like two little lights under the OBS that tell you when there's something going on.
The
But if we
input,
want to
yeah.
make sure that there's like details, like not too loud, not too soft, not mono, these things, then Zalus will do the same thing that Shiz does and tune in and just tell me whether or not it sounds okay. All right, next. Did everyone settle into these tech stacks naturally, or were you guys collaborating from the beginning? Just for speeding, I'll answer. It's random.
Yeah.
We didn't know each other until like recently.
Yeah.
At least not on the tech stream part now. I think we've all kind of come to similar conclusions. Not identical, of course. And then we just kind of got together and talked about stuff and got dragged into a panel about it somehow.
Yeah, like I wasn't using the load balancer originally, for example. I was using multiple servers chained to each other, and then I got this idea from James. So yeah, like we've shared stuff, but initially pretty much individually.
Next question. Tell me about your worst internet problems.
I switched my ISP connection the Monday before the first AnimeltUP, because I realized that COVID had overloaded Japan's PPPoE endpoints, and I was getting like 5 megabits down, which is not going to cut it. So I signed up for IPv6 with DS Lite, like something like 6 days before the first AnimeltUP online, and it worked.
I've got another one about that as well. One episode of Pon de Beats Live we did from a physical venue where it was just us, the DJs, and a few people from staff. And we all got set up, say, an hour beforehand, and then we realized that the venue internet actually blocked Twitch, which is a problem if you want to stream to Twitch. So I ended up setting up a last-minute VPN on an intermediate router that I flashed to OpenWRT, and that made it work. But I was very, very sweaty at that point.
I hear Optimum is a good internet service provider. Just wanted to throw that out there.
I actually switched over to a remote setup similar to the one that Sean describes, because when we were having fires in Northern California, I was afraid that my power might go out during one of the weekly streams. Fortunately, it didn't. But that's probably the thing that scared me, saying, I want to move the OBS out into the cloud also.
I think someone asked about the space before the stream URL.
Oh yeah.
So what's the story behind the space? Sorry, I missed that.
Yeah, so the story behind the space before the stream URL is that we were testing our setup with Jackazit at the time. And we were having issues getting it to work because we did the thing that I just told everyone not to do, which is to copy paste the entire URL into the RTMP custom server window. And then my BrainShit, good friend, noticed that it was working for him, and that was very, very weird. And he's like, okay, what is going on? Then he put a space in front of his URL accidentally just from copy pasting it. It turns out that having a space in front of URL, so OBS has multiple ways to stream to external servers. It has a built-in RTMP streamer as well. If you put a space in front of your URL, it will not detect it as an RTMP stream and will just redirect it to the default FFmpeg streamer, which will parse the URL and set the parameters correctly. So it's an OBS parsing error, in other words, and FFmpeg just happens to fix it up for you.
I think this one was good for Marcan. What would you suggest for live visuals if you don't have a VJ available?
Good question. I mean, I guess you could have some kind of like visualization in the background or something like that, but I'm not really sure. Like one thing that we've done is if you have a VJ and the DJ in different places, you can certainly chain them, right? Which is BrainShit does that. But if it's just yourself, I actually don't know. Anyone else have any ideas?
I've had DJs use Virtual DJ for that. They'll VJ themselves.
Makes sense.
Okay, and then actually, I think Marcan, you answered this last question. How do you add a VJ along with the DJ to the stream?
Yeah, so you basically just do what we do, except you add one link to the chain, right? So the VJ will have OBS, and they will have the DJ in as a source, and they will be streaming to whoever's doing the mixing, and then the VJ can overlay themselves. They can like green screen themselves or something like that. So what BrainShit does is like the shot is static from the camera, and the VJ overlays onto certain parts of his furniture. But you can also have a real green screen and have the DJ green screen themselves onto that. There's different ways of doing it, but basically anything you can mix into OBS, it makes sense. And the idea is that since the DJ is streaming to the VJ is getting audio from the DJ in real time. Like, the lag is it's a chain of lag, right? So it doesn't matter if the VJ hears the DJ late, because they're going to be VJing to the audio they get and streaming that out to the final destination, right? So there's no issue with, like, as long as you have a chain of people sending audio, the lag doesn't matter. It only matters if you're trying to go backwards in the chain, right?
Right.
And by the way, the chain is about 2 seconds for a typical OBS to OBS stream, in my experience.
And so, Sean, I think you once had like people dancing, right? Otake people dancing along to it. How did you do that?
That runs into the latency issue. I mean, if you actually watch the video, it's clearly off. But we just use Zoom, and Zoom has and a lot of VoIP has this option, has ability to share audio. So all I did was I piped the monitor output out through Zoom and share audio. So again, it's off by like 1.5, 2 seconds, which isn't great for coordinated Otage, but it was the gag. I mean, I certainly wouldn't use it if I was actually trying to be like, hey, do calls over this. Like, it would be off.
Then question, do you have MIDI controller recommendations? I think Marcan and I both use the Nano Control too. It's not super expensive, and it's got a ton of faders.
Yeah, it's super cheap, and it's super just flexible. Really, you can use it for anything. So if you just need a bunch of faders and knobs, yeah, I recommend that one. Also, honestly, I've used it has like the M and S buttons for mute and solo, but I use it for monitor and stream, which is great.
If you
I use every button for mute. And then honestly, like, even though I don't use the keyboard anymore, right? The MIDI keyboards are cheap, and it's like a ton of buttons. And so if you're just getting started, go for that. You don't need getting the DJ XP1 working was a lot more code, because I had to program the light behavior and all of that. But you don't need to start with that. I think a keyboard and the Nano Control, those would be fine.
I had more controller fun for the physical AnimeltUP when I was doing lasers, because before I became a stream operator, I was supposed to be the lasers guy at this event, and then the whole physical thing kind of went away, and I was using a keyboard controller plus pads for that, and that was more fun. There's a bunch of code behind that one.
Are you certified as a laser safety guy for venues?
No, but I have actually read the requirements.
All right,
and we made sure it wasn't hitting anyone. It's we don't do audio scanning. It was all over people's heads.
Oh, cool. Okay, I think that's it for the questions, and we're hitting the top of our time. So, thanks to the audience, thanks everyone for joining us, and thanks to all the panelists for providing this great content.
Thank you very much, everyone.
Yeah, thank you.
Yep, thanks, guys.